Dr. Zulfaqar Sa'adi. People call him Zul Junior. I am Zul Senior. So the title of this presentation is Spatial Uncertainty in Rainfall Projection for Peninsular Malaysia, assessing of the top performing GCMs under worst case scenario. With that, the floor is yours.
Okay, thank you, Chairman and Co-Chairman, for having me here for presenting my works today. So basically what I'm doing is I want to assess the quality of GCM, the top performing GCM. I find out the top performing GCM first, and to see if it can simulate the whole Peninsular Malaysia spatially equally or not. That is the question. So what we are using is we use GCM, Global Climate Model. So Global Climate Model is different from climate prediction model. So climate prediction model, usually we use that model for model the natural processes. So it's kind of quite easy. We know that naturally how it's happened in the world, we can make a prediction. But for GCM, we use it for projection, because in the global climate change model, we want to kind of project how climate change happen because of human behavior. What we are doing today, that will change in the future. So it's quite tricky and quite difficult. Then all of this will introduce uncertainty in the climate change model. So we don't know how human will behave today, right? And in other places and so forth. So a lot of SSP has been produced, worst case scenario, very good scenario, middle of the road scenario, based on we try to predict human behavior that will induce change in the climate. So that is GCM, global climate model. That is what they try to simulate. How climate is changing because of human action. So so usually when we do modeling, so my core research is more on the global climate model. I do modeling. So we have basically like this downscaling step. We have like start from input data, we do select downscaling method, process the data, we have output, evaluate, and then we try to communicate all the results. And each of these steps have uncertainty. Like for example, we have GCM structural uncertainty. This is very core. Every climate modeler have different model. There is about 105 climate model. So this huge model, we don't know which model is better than others. So that is uncertainty also. Initial condition, parameter, what they use parameter, scenario uncertainty, like we have SSP1, SSP2, 3, 5, and all of these scenarios have uncertainty. And what method we are using also introduce uncertainty. And when we processing the data, because some model they have different resolution, so we need to kind of make adjustment to the resolution. Then that is also introduced uncertainty when we try to interpolate the data spatially or temporally, and then temporal aggregation when we try to aggregate the data from daily to monthly, something like that. That's also introduced uncertainty. There is natural variability uncertainty, model resolution, and impact model. And when we try to evaluate the model, we validate. There is a lot of statistics, hundreds of statistics. So which statistic is reliable to justify which model is the best, and then how we communicate our model, and especially for the projection of the horizon uncertainty in the future, from the near future to the far future. So usually in physics, sometimes people do near future, mid future, or far future, or near future or far future based on 30 years in the future. 30 years from maybe 2021 until 2060, about 40 years. More, as long as it is more than 40 years, that is one climate cycle. It's not, in terms of climatologists, it's not very far, it's only one climate cycle. And then from 2061 to 2100, another climate cycle, we call it future projection, far future, in the far future. So we try to simulate how the future, so that projection also have uncertainty also. So, but in my case, usually I will use input data. We will, this is my usual frameworks of downscaling, I will use a bias correction method, and I will try to find the best method for bias correction. Scenario uncertainty also I try to reduce by using all the scenario, project all the scenario that are available, that commonly available, then process the data by using interpolation and try to find the best interpolation method. And then, in this case, for this study, I will just focus on model resolution uncertainty, which is in terms of spatial resolution only. And then we evaluate, we use a lot of validation process, matrix and so on, and then we try to communicate our results. So this is my study. I will use, for this case, we will focus only on model resolution uncertainty, spatial resolution. Spatial means space, not temporal one. So we will focus on SSP 5.8.5 because SSP 5 is the most worst case scenario and the highest uncertainty. So I want to find out the model that can simulate the most difficult scenario. And then I will using bias correction by using linear scaling and then using bilinear interpolation to make a fair comparison between the model and then use validate the model by multiple statistical methods. So this is the study area. We have Peninsular Malaysia. So historical data, we use observed data chips rainfall dataset, which is a gridded dataset. We have about 178 grid points available for Peninsular Malaysia, about 0.25 degree. So this is the available dataset that we use. A lot of study already validate this dataset, so it's kind of quite reliable to use for historical dataset. It starts from 1981 to today. Almost every month they will update it now. So it's more than 30 years, so we can simulate climate. Because climate is 30 years. You cannot do a climate change assessment 10 years or 5 years, you cannot. So you must have dataset more than 30 years. So this dataset we have from 1981. Why from 1981? I always ask this question, why certain data start from this year, this year, this year? Because I find out that from 1981 they start increasing. If you see climate change, especially temperature, they start increasing, emissions start increasing, especially start from 1981. So I think that's why the CHIPS dataset, they start from 1981. And then why I want to do this spatial resolution uncertainty. So when I read a lot of paper in Malaysia, they said climate variability is very high in Malaysia. So I asked myself, is it? So I don't like subjective answer like very high variability or something like that. So I try to find out by myself objectively. So I do some statistics. Just simple statistics first, like mean rainfall, median, CV, coefficient of variation, standard deviation, and skewness, and then find out that over the space of Peninsular Malaysia, that is different. How variability is different between some part of Malaysia, especially in the northern, east coast, and the west coast. So it's different. And then I do another statistic again by using Morgan I and GCM. So the value for Morgan I is about 0.2, is positive. So that means there is a rainfall value is spatially clustered. That means there is a cluster. That means there is a variability that exists there. And then the value for GCM is 0.7, quite high, close to 1. So there is a moderate positive spatial autocorrelation. So there is high variability in all kind of between medium and high variability of climate in Peninsular Malaysia. So indeed, that climate in Peninsular Malaysia is objectively variable, highly variable. So and then I try to check which model is the best. So when I see the model based on different metrics, there is 9 metrics, there is statistical metrics. So different models have different performance across Peninsular Malaysia. So how we want to select the best model for Peninsular Malaysia? Based on different metrics, also they give different model that is the best. Like, but more or less when we look visually, we can find out that CMCC, ESM2, and SESMI, CCM, FB2 is kind of the best here. Like they simulate a lot of places in Peninsular Malaysia, and that is the one of the top model. This is among 27 models that I selected. So the aim is to make a we want to find the first top performing model. We filter the data first from 105 model. We want the we use a monthly rainfall. We use a AO GCM model. We want to model that have historical and SSP5, and the resolution in 100 kilometer, and sample member is the initial condition parameter for GCM R1, I1, P1, and F1. This is the usual one that people use. So we filter it up to 27 model now. Now we have 27 model to compare. So from this model, we use a model selection by using multiple statistical metrics and CTI to aggregate the model and change classification for 178 grid point by using 9 metrics. So that is about 43,000 combination. And then we aggregate all the data, and then we come up. The best one is MCC ESM2 and the second model. And then I'm not satisfied. I tried do another statistical analysis to find the best model. And when I compare with all our study previously by using another method for selection, most of the models come out with CMCC ESM2. So we use this model to simulate to find out which area is the model can simulate better or not. So we find out that the model can simulate better in the west coast of Peninsular Malaysia, mainly under all the metrics, and it cannot simulate in the northern and in the east coast of Peninsular Malaysia. And then that is the result. And then I want to understand why. So the why is why there is low performance in the east coast of Peninsular Malaysia, because we all know, if Malaysian, they know this is very high extreme rainfall here. Extreme rainfall, so model is quite difficult when they try to simulate extreme rainfall. And then this area is a coastal area. GCM is a very big model, so if we want to zoom into the coastal area, sometimes the box is not captured very well, right? And then there's the wind very strong here. Topography and wind direction is all this mechanism that producing rainfall is very active here, so it's very difficult to model this area. That is the reason. So, and another study that we found out is that this region is actually we classified as the East Coast region, and this is the Northeast zone and interior west zone. So the characteristic of this area, they have a very high rainfall during December. But why only this area have a very low GCM performance? Because actually this zone here and Southeast zone also actually East Coast region. But why this area is still very high low performance GCM? I think maybe because of the topography here, not just because of the monsoon. Topography might play a key role here compared with the monsoon. I think, and then this is the projection. We do projection, and we found out the west coast increasing rainfall. Exactly what happened now. Like in Selangor, they're flooding. We never had flooding in Selangor, and then recently the more flooding. The projection exactly tell us something like that. And in the northern area, lower rainfall also happening right now. Heat wave. So in Kedah there is no rainfall, something like that. The same projection are happening. So because the model can simulate very well in the west coast, so the model is correct. I can say the model is quite correct at that part of the peninsula. I think that's all.
So thank you so much, Zul, for the very interesting, insightful, and ability to predict what is going to happen in the future. Okay, the next presenter will be Dr. Nur Eliza Alias. The title is Probable Maximum